Aloha BC, let's get it, get it. All right, here we go. The last one of this terms of Judgment Week, and then we have one more that we're going to do next week. So just like 1, 2, and 3, make sure you print this out, do that work on your own, take a picture, send it to me. Can you get it done in under 22? All right, can you do it? We got a little Euler's method here. I know most students like that. So let's see if we remember all of these little things. All right, let's get it going nows. All right, so it says use Euler's method. Whoops, sorry. Trying to get my screen up. Let's use Euler's method, all right? And do we remember Euler's method? We're going to do 2 steps, and we want to go from 0 to 1/2. So remember, the first thing I have to do is check out my step, my change in x, which would be b minus a over the number of steps. So it'd be 1/2 minus 0 over 2 steps, which would be 1/4. So those are going to be my steps, righty, right? So remember, we have an x column. We've got a y column. We've got a slope column, right? M equals dy over dx column. We have a m equals, whoops, my bad. We got a change in y is equal to m times dx column. And then we have our new y, right? We got our new y. All right, so let's go ahead and see this. So we start with our initial condition, which is 0, -2. So we start 0, -2, and we find our m. Our m is simply using our slope formula up there. There's nowhere to put an x of 0, so we put in a -2, and we get a, what would that be? 4 plus 2, which would be 6. Okay, and then it says, what's the change in y? Well, the change in y then would be 6 times your change in x. Your change in x was 1/4, remember? So if we do that, we get 3/2. So what's my new y? Well, my y when I started out was -2. We're going to add a 3/2 to that, and that would give me a, that's 4/2, a -1/2. So that is my new y. My new x is going to be 1/4. Why? Because my change in x is 1/4. And my new y is going to be -1/2. Remember, I got to keep on going until I get an x value of 1/2. All right, so let's keep on going. And to keep on going, right, it's just a process. We find the slope again. So this time I'm going to put a -1/2 in there, and I would get, let's see, that would be 1/4, right, plus a 1/2. So that'd be 2/4. So that'd be 3/4. Okay, and then I'm going to find my change in y, and my change in y is going to be my slope. My new slope at this x value of 1/4 would be 3/4, and I'm going to multiply that by the change in my x, so I'm going to get 3/16. So then my new y is just going to be my old y, which was -1/2, and I'm going to add 3/16 to that, right? And that is just 8/16. So -8/16 plus 3/16 is -5/16. So my answer, because now I'm at 1/2, is just -5/16. Boom! That's all the work that leads to my answer using Euler's method. It says right here that would be worth a couple of points on this year's AP exam. This teacher did a really great job of hitting every point you would need to get that 5 go bond on the AP exam. All right, here we go. We all know when we see this year, it's going to make you think to do a little L-hop. All right, so remember, whenever we do L-hop, we want to break it into the top and the bottom. And remember, we've said so many times how important that is for this problem. Okay, so let's go ahead and try direct sub first. F of 0 plus 2. Now, the bottom's just going to be 0 because 2 times 0, cosine of 0, right? That's going to be 0. F of 0, it says initially is -2. It says that. Remember, that's an initial condition. So I get 0/0. Do something else or L-hop it. All right, now what do we do when we L-hop it? And remember, you should say right there, you got 0/0. So you should say, I'm going to L-hop it, right? But make sure you write out the whole thing, obviously. We are going to use L'Hopital's rule. And what is L'Hopital's rule at home, bases? We just take the derivative of the top. We take the derivative of the bottom. Well, that's going to be a product rule. The derivative of cosine would be -sine of 2x, and then you're going to chain it times 2, plus the derivative of 2x, which is just 2. Okay, and this, whoa, maybe this could work now. Let's go ahead and try our direct sub. We get f prime of 0. Okay, and on the bottom, that's going to turn into 0, but that's going to turn in just Niban, dos, okay, or 2. So what's f prime of 0? Well, f prime of 0, well, okay, that's the derivative there. And remember, we're going to put a 0 in for x, we're going to put a negative 2 in for y, and we get 6 over 2, which is tree. Almost like it worked out perfectly for us in my class, right? So we get a tree. So you get probably 2 points for that bad boy. So right now, you're probably a little out of fault. And then we go to C. All right, and what does C say? Well, C, oh snap, it says find an expression which solves the differential equation with the initial condition. Okay, so we're going to solve it. That means a little separate and integrate. But you know what's interesting here? It says it is not necessary to have your answer in that form. I wonder what that means. I bet you if I keep on solving this guy, it's probably going to make some sense. So let's do it. All right, let's separate, which would be 1 over y squared. I'm going to factor this because I already have an idea of what is going on. 1 dx. And if you look at that side there, everybody should say, let's just cover up that bad boy, or partial fraction decomposition, right? But let's just cover up that bad boy. So what would make that y right there a 0? Well, it'd be 0, duh. So we're going to cover up that. We're going to put a 0 in, and I get negative 1. So we get negative 1 over y, right? Because that is what would make it 0. That's the cover-up method. Now let's look at the y minus 1. Let's look at what's in the parentheses there. Okay, and what does the rule there? Well, if I plug a 1 in, that means I get 0. So let's cover that up and plug in a 1, and how nice. I just get 1 as my answer. So remember, your coefficients go up here for that, right, class? Okay, and that's equal to 1 dx. So now we just got to do a little antiderivatives. Negative 1 would be negative natural log of the absolute value of y plus. This would be just the natural log of y minus 1, and that'd be equal to a little x plus c. Oh, snappity dappity. C showed up, so let's find that c. So let's plug in that negative 2, and we have an absolute value. So it's the natural log of 2 plus the natural log of, that'd be negative 3, but the absolute absolute value of negative 3 is tree. And then we put a 0 in for that, and we get c equals that bad boy. And remember, we could simplify that to be fancy, which would be the natural log of 3/2. Okay, so we're going to come back over here, and we're going to plug that in. Okay, and we're going to put the natural log of 3/2. And then I'm going to come up here, and I'm going to do some more work. Right, and it does say that. So could I stop right there? I don't think so, because I have these absolute values, and I'm going to have to account for those bad boys, right? So let's account for those bad boys. So I'm going to rewrite this side. There's a minus sign. So I could rewrite that as the natural log of y minus 1 over y. And remember, you got to be good at your pre-calc days to understand why we do that. So hopefully you guys do. I would think you would have to go this far, even if those were your directions. So now we're going to change it to an exponential, remember. And then I think you're done as long as you get rid of that absolute value. So it would be this. Okay. And then we're going to go ahead and do our little plus or minus. And then I think you would be done. And it would be plus or minus. But remember, I have to pick the plus or minus. And remember, this is just really e to the x times e to the natural log of 3/2. And then remember, so that'd be y minus 1 over y equals, it's going to be the positive actually, because remember, this piece here is going to be 3/2 e to the x. And then how do I know it's going to be positive? Well, you plug in your initial value. If you put a 0 in here for x, you get 3/2 on that side. If you plug a negative 2 in here, you're going to get a positive 3/2. So that's how I know that would be the answer, okay? And it says you don't have to necessarily solve it. And guess why? Because you can't, okay? All right, I think they just wanted to hit everything here. So that's why we had the cover-up method in that one. Okay, and then it says, hey, does the given differential equation model logistic growth? That's like minus licked, remember. And if you remember from our formulas here, that for it to be a logistic growth, it's got to follow this format. So make sure you memorize your formulas here. Okay, remember, that would be logistic growth. And remember how logistic growth would be used, okay? If not, come to Google Meets and we'll work on that stuff. But this is not of this form. It's close, but it's not. So this is not logistic growth, okay? Now, what I am going to do is, I don't think that took us too long to do that problem. I hope you guys were as successful as I was. But I'm going to go ahead and show you the solutions. There you go. Euler's method, worth 2, this teacher thinks. Part B using LHOP. L-hop in that bad boy, you get 2 more. 5 points, obviously, for solving your separating variables and all that good stuff. And then D. You know, sure, they could definitely bring something up against logistic growth, right? The great thing about this teacher bringing this stuff up is he really focused on everything in terms of BC with a little AB intertwined into it, what you would need to know. All right, and then everybody knows what our fifth and final question is going to be that we're going to work on next week, right? Little Taylor, probably a little ratio test, right? Test those endpoints. And so that's it. Alohas. Come to Google Meets. I miss seeing you guys. It's truly awesome to see you guys. The videos you guys are sending are amazing. I know they're helping to push up those grades big time. Get those videos done. Get that grade up heading into college. Aloha.